First, we need to find the gradient of our function f of x, y, z equaling x times e to the 2yz. The gradient of f is a vector, and the first component is going to be the partial of f with respect to x, which is going to be e to the 2yz. The second component is going to be the partial of f with respect to y, which using the chain rule here is going to give us 2z times x times e to the 2yz. And the third component is the partial of f with respect to z. And again, using the chain rule, that's going to be 2yx times e to the 2yz. There's our gradient of f. Now we're supposed to find the gradient of f at the point P, which is point 203. So we're just going to plug 2 in for x, 0 for y, and 3 for z, and we will get e to the 0, which is 1. We'll get 2 times 3, or 12, times e to the 0, which is 12. And since we have y down below here, 2yx, we're going to get 2 times 0 times x times e to the 2yz, which is 0. Now we need to find the rate of change of our function f at the point P and in the direction of the vector u, which was given to us. That's the vector 2/3, -1/3, 2/3. And to find the rate of change of our function at a point in a given direction, we just do the dot product of our gradient with a unit vector in the given direction. So what I'm just going to do here is check the length of this vector u to see if it's already a unit vector. The fact that u was used for it suggests that it might be a unit vector. So just find its length, and so we'll take the square root of the squares of the components added together, and yes, we'll find out that we've got the square root of 4/9 plus 1/9 plus 4/9. That's going to be the square root of 9/9. And I wrote that wrong. That last one should be 4/9. Okay. And I'm not going to go back and redo the video. So it's 4/9 plus 1/9 plus 4/9, which is 9/9. Square root of that is 1. Now we are taking the dot product of our gradient evaluated at the point P with the unit vector, and that will give us the rate of change of our function f in the direction of the unit vector. Okay, so we're doing the dot product of 1, 12, 0, which is our gradient evaluated at the point 203, with our vector u, which we found out is a unit vector. And it's just plug and crunch. We're going to get 2/3 minus 12/3 plus 0, and that's going to be -10/3. So there's our rate of change of our function f in the direction of the unit vector u.